Hey there guys, in this video we're going to be solving a really nice equation with radicals. But before we go on, consider subscribing and ring the bell to not miss my latest videos, and hit the like button if you find this video helpful. So first of all, let's go ahead and start with the domain. Obviously this, and this have to be greater than or equal to 0. They have to be non-negative. So we have x minus 4 is greater than or equal to 0. And x plus 4 is greater than or equal to 0. And the same thing goes for x squared minus 16. So from the first one, I'm going to get x is greater than or equal to 4. From the second one, I'm going to get x is greater than or equal to negative 4. From the third one, I'm going to get x squared is greater than or equal to 16, which means that either x is greater than or equal to 4, or x is less than or equal to negative 4. Now, since we have and between these conditions, we need to find the intersection of the solutions. And if we do so, we will see that the intersection is x is greater than or equal to 4. So let's go ahead and rewrite the problem down here. We want to solve the square root of x minus 4 plus the square root of x plus 4 minus 2 times square root of x squared minus 16 equals 2x minus 12. And we know the domain is x is greater than or equal to 4. Now, looking at the equation, we can clearly say that we cannot isolate one radical and then square both sides in order to solve for x. We need to do something else. And the first thing that I'm going to do is to talk about square root of x squared minus 16. Now, the square root of x squared minus 16 is special because x squared minus 16 is a difference of two squares. Therefore, this is equal to the square root of x minus 4 times x plus 4. Now, since x is greater than or equal to 4, I can go ahead and say that this is equal to the square root of x minus 4 times the square root of x plus 4. So basically, we have the sum of these two numbers and their product on the left-hand side of this equation. And if you look closely, we will see that 2x, which is on the right-hand side, is actually the sum of their squares, because 2x is just the same thing as x plus x, and x plus x can be written as x minus 4 plus x plus 4. Now, notice that x minus 4 can be written as the square root of x minus 4 and then squared, and the same thing is true for x plus 4. So we can say that 2x is the sum of their squares. So we have their sum, their product, and the sum of their squares in our equation. So let's go ahead and use substitution to make the equation much simpler. So let's go ahead and say that a equals the square root of x minus 4 and b equals the square root of x plus 4. So our equation is going to be the sum, which is a plus b, minus 2 times the product, which is negative 2ab, and this equals the sum of their squares, which is a squared plus b squared, minus 12. So at this point, we need to go ahead and solve this equation. Let's go ahead and move these to the right-hand side in order to have everything on the same side. So we're going to have 0 equals a squared plus b squared plus 2ab minus a minus b minus 12. Now, notice that this is a perfect square, and it is equal to the quantity a plus b all squared. And notice that I can factor out a negative 1 out of these two. So we have negative the quantity a plus b minus 12, and this equals 0. Next, let's go ahead and use another substitution. And let's go ahead and say that u equals a plus b. So we have 0 equals u squared minus u minus 12. So we have a quadratic equation. So in order to solve this, let's go ahead and factor the right-hand side. It can be factored as u minus 4 times u plus 3, and the product is equal to 0. Therefore, based on the zero product property, I can go ahead and say that u equals 4 or u equals negative 3. Now, remember that u is equal to a plus b, and both a and b are positive quantities because both of them are equal to some square root. Therefore, u must be positive. So this is a valid solution, but this is not. So we have found out that u equals 4, and from this I can say that a plus b equals 4. Now, since a is the square root of x minus 4 and b is the square root of x plus 4, we have the square root of x minus 4 plus the square root of x plus 4 equals 4. And at this point, in order to solve for x, we need to square both sides. So we're going to have x minus 4 plus x plus 4 plus 2 times square root of x minus 4 times the square root of x plus 4, and this is equal to 16. Now, since x is greater than or equal to 4, I'm allowed to say that this is equal to the square root of x squared minus 16. So we have 2x plus 2 times the square root of x squared minus 16, and this is equal to 16. Now, since everything is divisible by 2, I'm going to go ahead and divide everything by 2, and I'm going to get x plus the square root of x squared minus 16 equals 8. And now, in order to isolate the square root, I'm going to subtract x from both sides. So I'm going to get the square root of x squared minus 16 equals 8 minus x. And finally, we need to square both sides again to get x squared minus 16 equals x squared minus 16x plus 64. And now this will cancel this one. So I'm going to get 16x equals 80, which gives me x equals 5. Now, for the final step, we need to go ahead and plug this value into our original equation and see if it's a valid solution or not. So we had the square root of x minus 4 plus the square root of x plus 4 minus 2 times the square root of x squared minus 16, and this equals 2x minus 12. So if x equals 5, we're going to have square root of 1 plus the square root of 9 minus 2 times the square root of 9, and this equals 2 times 5 minus 12. The left-hand side is going to be 1 plus 3 minus 6, and the right-hand side is going to be 10 minus 12, and both of them are going to be negative 2. Therefore, x equals 5 is a valid solution. And this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you find this video helpful. Hopefully, I will see you later. Goodbye for now.